In this tutorial, we'll cover the basics of LEGO model simulation in MoveMyMoc and some transformations. The main idea behind this game was to create a sandbox playground where players can play with LEGO machines in an interactive physical environment. While online multiplayer is not yet supported, the possibility of having fun with something together was more important than accurate physical simulation. Also, many Technic models aren't actually enjoyably playable with their proper physical parameters. Proper physical simulation of complex Technic models is very hard, especially in real time in an online multiplayer environment. For example, some really elaborate Technic suspensions are really awesome to build and play by hand, but they would give an awful driving experience at high speeds. A key tenet of the game to keep in mind is that moving parts of models aren't physically simulated. They are rather animated, but they still let you create models that interact nicely with the physical environment. LEGO models will be simulated as so-called rigid bodies. The LEGO pieces will have their outer bounding box as colliders, except for some special parts. This can give surprising results in case of slopes and wedges, so keep this in mind. While you can configure the total mass of the models, the mass distribution will be determined by these bounding boxes of parts. You can turn off colliders on specific parts or entire submodels by adding the no collider behavior. This can come useful when certain, lower parts of a car would be hitting the ground. You can specify a part as the center of mass of the model. This can help stabilize cars and is especially useful with large machines that would otherwise easily tip over. Now let's take a look at some animations. The game uses the L-draw coordinate space, which means that a single brick piece is 20 units in width and 24 units in height. Technic elements follow the brick width as a unit, so one pin distance is 20 units. Rotation angles are measured in degrees, so 360 degrees is a full circle. Animations can take built-in values as inputs, for example steering and gas pedal states or wheel roll. Further controls can be configured under Controls. We'll discuss options in detail later. Let's now just add a single control. The input keys R and F will be bound by default to increase and decrease the value. It will change 1 unit in 1 second of pressing. We can directly rotate a piece or submodel by configuring a rotation behavior on it. We select the control value as the input of the rotation. Set the factor to 90 so that an input value of 1 rotates the part by 90 degrees. We can adjust the rotation axis and the pivot coordinates of the rotation. We can also specify an external or an internal piece as the appointed pivot. This allows easier setup when the part is rotated around an axle, a pin, or a hole. In certain cases, the game will try to auto-configure the rotation pivot for you, like you see in this example now. The rotation of another part can be used as an input for a rotation. This is useful when setting up gear systems. Here we first need to select the rotation pivot and axis, as it was not automatically detected. The direction and the factor of the rotation needs to be manually set up now, according to the ratios of the connected gears. Here the ratio is 12 gears to 20 gears. This will be likely improved later by auto-detecting which gears are connected. When the gear connection option is used, the system will try to identify the relative rotation of the two elements, which is necessary if a gear is revolving around another. When turned off, the system will find a close stationary reference and determine the source part rotation relative to that reference. Translation of pieces can be set up similarly. When used with a single valued input, you need to specify the translation axis to specify the desired direction. You can also use the follow part option that will follow a given pivot point in all axes. This is similar to a hinged connection. We'll cover hinges in a later video. A part translation value can also be used as input for a rotation. For example, when the motion of a gear rack is rotating a gear. Gear racks have 2.5 teeth per a single stud distance of 20 units. This means that a displacement of 8 units will move 1 tooth of gear. In case of this 12-tooth gear, that's 30 degrees, so we need a factor of 3.75. Don't worry, I promise there will be some auto configuration here soon. This scenario can also be set up inversely when the gear rack displacement is determined by the gear rotation. I hope you found this video helpful. In upcoming videos, we'll cover setting up some common models, including car steering and basic machines.